coming to the greenhouse effect. The greenhouse effect is pretty simple. It is like every body that is at a particular temperature above zero gives out radiation. The sun at 5000 degrees centigrade, the surface temperature, is giving out radiation at a particular wavelength. It is in the visible spectrum, it is in the infrared and the ultraviolet spectrums. But whatever strikes Earth will also hit back because of the higher temperature of Earth. The higher temperature, I mean to say, is that it is not zero. Any particular temperature above 0 Kelvin will give radiation. So for the temperature at which Earth is, the radiation that comes out of Earth, the reflected radiation, is in the infrared spectrum. So the infrared spectrum is what the greenhouse gases will reflect. The solar incoming radiation is not in the infrared spectrum, but the outgoing heat radiation is in the infrared spectrum. So this is what the greenhouse gases will reflect back onto Earth and trap heat. And the greenhouse gases were responsible for mass die-offs in the past, planetary scale extinctions. It is recorded very well in the planetary history, and you can figure out that from paleoclimate records. So what are these major greenhouse gases? Carbon dioxide, which was at 280 parts per million before the start of industrial era, and which is today at 412 parts per million. Methane is a very powerful greenhouse gas. It is 86 times more powerful on a 20-year time scale. Instantly it is 150 times more powerful, or even more. And over a 100-year time scale it comes down. It is an exponential graph where it comes down to around 26 times as powerful as carbon dioxide. And when methane breaks down, it breaks down into carbon dioxide. And then we have nitrous oxide. Most nitrous oxide is a product of agricultural activity and from burning of fossil fuels also. So this is more powerful than methane. It stays somewhere around 300 times as powerful as carbon dioxide. And then we have the chlorofluorocarbons, CFCs, and the replaced CFCs are stronger greenhouse gases. Then we have a plethora of different smaller quantity. They are smaller in quantity, but they are also being released. There are greenhouse gases that are 15,000 times stronger than carbon dioxide, but we have a minuscule amount of it in the atmosphere current now. So we'll be focusing on carbon dioxide, methane, and nitrous oxide. And you also have to realize that there's a redundancy in the system. Once carbon dioxide is released today, that carbon dioxide will show its full scope, full impact in at least 10 years from today. And it will go on for the next 10,000 years. At least 10,000 years. And the full impact would be felt between 10 and 40 years from today. So whatever heating we have seen today is because of, if now it is 2018 and we've only seen impact of carbon dioxide that was already released by 2008. And this makes things interesting. And the temperature rise of 1.5 that we've already observed corresponds to just 375 parts per million. Where are we today? It is at 412. And it is also worthy to note that this is something like a poison, but the poisoned person dies 10 years after being poisoned.